Hey, how's it going? I hope everyone's doing all right. I'm doing well over here, except my hair's kind of growing out, getting crazy again, and I ran out of product, so I'm sorry for the bad hair day. It kind of seems as though a small animal died on top of my head. But hey, that's life right now. It's all cool. Maybe later I'll shave it. I don't know. But I hope you're all doing well. I wanted to make this video for just a few reasons. One of the main ones was to talk about, the picture of the day, some things that are happening right now, just to share some other random things. I guess, this shirt, one of my favorite poems, just, general things that I think would be cool. I probably would have discussed these things in class regardless. So, let's kind of get right down to it. Okay, so this research just came out recently. So, bringing it back, do you remember when I asked you to do this Stellarium assignment way long ago, like, at the beginning of last week, where I asked you to graph some of the planets along those different grids, the as and the alt grid? So, what you should have seen is actually some ellipse. I was actually looking at your assignment and well, it seems like some of you turned it in, but the file didn't upload. So if you can, do that again, that'd be really, really good. But I was actually very impressed. Some of you did a really great job. I saw someone actually write down like all of the data, all of the lists of those points during those hours, and then they did actually an amazing job on their graph. Other people did pretty well. Some I saw a lot of effort, but it was not exactly what I was looking for. But hey, we live and we learn. If I'm not there to help you directly, it's going to be a little bit more challenging. So again, I'm just happy for those of you that have been doing the work. It's really, really cool to see you continue to try and learn. And I know it's rough for everyone right now for school and for many other reasons as well. But again, it's always just nice to see everyone try. So I appreciate that. Now let's get into the news of the day. So the star dancing. So going back to that assignment, if you would have seen it, you actually would have formed an ellipse similar to this. However, this is quite eccentric, meaning it's stretched quite a bit. The one you would have made would have been not nearly as eccentric. However, you would have made one of these, and then I think for the 24th hour, I think I did it for a day, it would have been a little off from where you started. So you'd see, you'd create one of these, and then you'd kind of, have the little dot somewhere near here, assuming you started right here, it'd be somewhere here. And if you did it, you'd continue to see this rosette that we see right now. So what this is, uh, of course, we know that at the center of our galaxy and at the center of most galaxies, there's a supermassive black hole. And it's always interesting to try to find out the mass of these supermassive black holes because a lot of times there's some cloud, some interstellar clouds that are just nearby that kind of block our view of it. And there's just these it's tough to do it. So again, going back to things that we have learned before, I don't know if you remember, but we learned one the escape velocity of planets and of the sun, and also the excuse me, and also the period of planets going around the sun, and this had to do with the mass of the sun and the planets. Um, as well as the distance they are away from the sun. Do you remember that? So doing that, we were able to find out how long it would take, or these different things to regarding the year of these planets or the speed at which they go. Hopefully, you do remember that. I know some of you groaned when I made you do these calculations. But they were for a good reason because this actually relates to what we're seeing right now. Okay, so those two things combined, we are actually able to find a more accurate measurement as to the mass of the supermassive black hole. at the center of our galaxy because we're able to identify the star that forms this pattern. So we've been following this star that's been going around the center of the black hole for about 3 decades almost, and that has given us roughly enough time to see two orbits around it. So 2 periods, 2 years of this star going around the black hole. Of course, it's not a year like our year, but it's a period for this star going around that black hole. So using all that data, we've been able to understand and to confirm something that we've known before is that in Newton's old laws, it would just be an ellipse like this. Okay, Newton's, Tycho Brahe's, Kepler's laws. It would just be one ellipse doing this the whole time, and it would just be that. But with the general theory of relativity, we understand that there is some variation to that, and I don't know if you remember, I also mentioned Mercury was one of the big influencers of us changing our whole idea about gravity because it didn't fit that Newtonian view before. To the point where they kind of created a new planet called Vulcan to, make sense of the gravitational field or the orbit of Mercury. So, they created the planet Vulcan to be like, oh, there's just a planet there, we can't see it. Then Einstein came, he made general relativity, and it helped explain the nature, the reason why Mercury went around the sun like it did, the strange orbit. And so we have seen that orbit before, which is this, but this is the first time we've ever seen a star do it around a black hole. So although we've seen this pattern before around a smaller body compared to a bigger body, we have never seen these two types of bodies, which helps again confirm the general theory of relativity. And I know, you might be like, haven't we done that before with the first time it happened when we were able to see a little gravitational lensing behind a solar eclipse and things like that? And hasn't it been shown, hasn't it been confirmed many other times? Yes. But remember, in science, just because it's a theory, although amazing, it's a great explanatory framework to explain most of what we see, that doesn't mean it's perfect. It just means it's, hasn't been shown to be wrong. That's how we always view theories. It's great and it's perfect, but they could always use some tweaking. But then when we see stuff like this, we're like, hey, it again just shows that this idea is rock solid and amazing. So it's just interesting both sides to be like, oh yeah, this just shows that our theory is that good. But then also, it's also incredibly interesting to find stuff when it's like this doesn't fit into that these known parameters. What do we have to do to change it? Like that's actually an exciting and cool thing. So when we looked at this, it made this cool pattern similar to what you would have done if you would have graphed those planets going around the sun many times over. You only did it for one day. Also, yeah, this gives us it helps us understand a more precise mass of the sun, of the supermassive black hole. And it's just super cool. It's just another new thing that we've seen. Here, let me show you this video. So if you trace it, again, remember, according to Kepler's laws, which still work pretty well in general, they're not absolute, but when it's furthest away from the large supermassive black hole, the star goes slowly. But when it gets close right here, you see it'll like whoosh, slingshot. It'll do it quickly, and the trajectory will change just a little bit. So I think that's super cool. And then you'll see it changes trajectory, and it'll keep doing that over and over and over again, which will create this structure that'll look like a flower, essentially, if you continue going for a long time, which is, I think, it's beautiful. There's more to talk about here, but that's about it. How about something, non-scientific? I don't know if you can see my shirt. It's pretty cool. I think I had this the first day. Um, Actually, it comes from one of my favorite songs of all time, specifically from the artist Frank Ocean, called Solo. Comes from the chorus, which says many things, but there's a there's a bull and a matador fighting in the sky, and then in hell there's heaven. That part doesn't matter, but there's a bull and matador dueling in the sky. He's talking about Taurus and um, the fighter. Oh my goodness, Orion. Orion. So he's talking about these two kind of constellations, and then people staring at them. If you do listen to that song, know that I do not endorse a lot of the habits that he mentions in there, but the song's great. The ideas are great, and I got this shirt because of it. Um, I know, not really perfectly, educational, but it's pretty cool. Now, uh, going back to those, photos and or videos of the day, going back to the photos or the videos of the day. This is a video of the day. So I know we've been hearing a lot about Corona. Let me change, your perspective of Corona for a bit. Actually, the reason why it's called the coronavirus is because it kind of looks like the corona of the sun. That's why it was called that. So here we're looking at the corona of the sun. So let's go back to what it originally was mentioned for, and it's this. And let's look at this. Look at these. We call it this rain. This coronal rain, which is beautiful. These solar flares that are just, uh, like I don't know. Isn't that beautiful? I hope you feel the same way. I think that's amazing. And then you can see right here they'll have a comparison to the Earth not long from now. Oh, there it is. Look at that. Can you imagine this rain just at the edge of the sun? That's nothing compared to it. But then it's like, oh hey, many of our you know our planet multiplied many times could fit within that little rain. Yeah, that's beautiful. I got shivers. I got shivers. Okay, I think that's most of what I wanted to talk about. I do have an assignment for you. Actually, I'll state that on Teams before I post this. But let me actually tell you what the assignment is, or before I tell you what the assignment is, it's relating to one of my favorite poems. So essentially, the assignment would be just find me something related to astronomy or the stars in general from some song or media or something like that. That'll be our assignment for today. Nothing crazy, but just share something with me. I will probably create an assignment where you can upload a document. You can either put a link to like a song and tell me a specific place to go, or maybe an artwork that's not NASA related, or maybe even a poem, something like this. Mine right now is a poem. I love a lot of Carl Sagan stuff, but this is another poem by W.H. I think Hoden. I forgot how to say his last Huden, but it's called "The More Loving One." So here it is. Looking up at the stars, I know quite well. For all they care, I could go to hell. But on earth, indifference is the least we have to fear from man or beast. How would you like it if stars were to burn with a passion for us we could not return? If equal affection could not be, let the more loving one be me. Admire, as I think I am, of stars that do not give a damn. I cannot see one and then say, I miss one terribly all day. And if stars were to disappear and die, I should learn to look and at an empty sky and feel its total dark, sublime, though that may take me a little time. That was the poem. I hope you like it. It's, it's one of my favorites.